Hello, you're welcome to today's lesson. Have you ever used a magnet to pick some paper clips before? Like this. Today I'd like us to learn about magnets and their properties. Magnets attract certain objects to itself, like this. They are used in the industries to lift heavy metals, while some people use them to pick certain things on the floor. Now, the first properties of magnets I'd like us to look at is magnet attract object to itself like this. So if you have these paper clips on the table and you want to pick all of them quickly, you just move a magnet over it like this. Next is all magnets have two poles, the North Pole and the South Pole. Look at it, it's written here N and S, the North Pole and the South Pole. This one also has north and south. Likewise, this other magnet, even though it's not written, it has North Pole and South Pole. Next is like poles repel. This is North Pole, this is another North Pole. Look at it. They repel each other, they do not attract. If you put them together, they'll be pushing against themselves. So let's put it on the table and test. This is North Pole, this is another North Pole. It's moving backward. Let's look at it this other way. It's repelling, it's going back. Why? Because here is the North Pole and here's another North Pole. It's repelling. So like poles repel. The next property is unlike poles, that is north and then south, they attract each other. Like this. Is attracting each other. Unlike poles attract. So the first property is magnets attract object to itself. It has two poles, north and south pole. Then like poles repel, and then now unlike poles attract, like this. Next is there is a magnetic field around magnets. A magnetic field is the region around the magnet where the effect of a magnet is felt. Look at it, if you put these paper clips around this magnet, just like that, it gets attracted to the magnet. Look at this one, and here. Next is the magnetic field is stronger at the poles. Look at it. The magnetic field of magnet is stronger at the poles, at the South Pole and the North Pole. Also, when you pass current through a solenoid, this is what we call a solenoid, it creates a magnetic field. So let's close this circuit and see if a magnetic field is created around here by putting some paper clips. So let's see. It has created a magnetic field around this part. So if you open the circuit, what happens? It has lost its magnetism. Let's do it again. See, it's not getting attracted to it. But if you close the circuit, see. So when you pass current through a solenoid, a magnetic field is created around this part. This is the technology that creates an electric bell. In our next lesson, we're going to be using this to make an electric bell. But before then, let's go over what we learned today about magnets. We said magnets attract certain objects to itself. We said they are made up of two poles, the North and the South Pole. Then like poles repel. Then unlike poles attract. We also said that there's a magnetic field around magnet, the region whereby the effect of a magnet is felt. And that field is strongest at the poles, the North and the South Pole. Then we said what happens when you pass current through a solenoid? It creates a magnetic field that attracts object to itself, like this. Thank you very much, and I'll see you next time.